Good afternoon. Myself Nandita PN from DAGS, and our group members are Marin, Nindu, and Jerry. And our topic is filter design in digital signal processing using Muller's method. So first we introduce what is Muller's method. Muller's method is a numerical technique used to find roots of nonlinear equations, and it extends the secant method by using quadratic interpolation instead of linear, allowing it to estimate roots more accurately. Starting with the three initial points, it fits a parabola through them and uses a quadratic formula to find the root. And Muller's method can handle both real and complex roots and typically converges faster than methods like secant or bisection method. So, get into the Muller's method. So, we first use a parabola. So, first is equation of parabola. Equation of parabola is P of x is equal to a into x minus x2 all square plus b into x minus x2 plus c. And here a, b, c and are constants, and we want to find a, b, c to get the root of the equation. We want to pass a parabola through the points. That is the first three initial points: x naught, f of x naught, x1, f of x1, and x2, f of x2. First we So this is the equation of the parabola. First, we pass the point x naught, f of x naught through it. So we get f of x naught is equal to a into x naught minus x2 all square plus b into x naught minus x2 plus c. And then the next point, x1, f of x1. So we get f of x1 is equal to a into x1 minus x2 whole square plus b into x1 minus x2 plus c. And then f of x2 is equal to a into x2 minus x2 whole square plus b into x2 minus x2 plus c, that is equal to c. So we get f of x naught, f of x1 and f of x2. Then we have equation 2 minus 5, that is second equation. So equation 2 minus 5, that is f of x is equal to c is the first equation. So equation 2 minus 5 gives that f of x naught minus f of x2 naught minus f of x2 is equal to a into x naught minus x2 all square plus b into x naught minus x2. And this is equation 6. And the next one is 3, equation 3. Equation 3 minus 5, that is f of x1 minus f of x2 is equal to a into x1 minus x2 whole square plus b into x1 minus x2. This is equation 7. And to get a and b, we define h naught is equal to x1 minus x naught, and h1 is equal to x2 minus x1. And also we define the slope delta naught is equal to f of x1 minus f of x naught by x1 minus x naught, and delta 1 is equal to f of x2 minus f of x1 by x2 minus x1. and this can be written as f of x1 minus f of x naught by h naught, and also f of delta 1 is equal to f of x2 minus f of x1 by x1. Then we defined x naught, x1, and also the slopes delta naught and delta 1. Then from equation 6 and 7, we can write f of x naught is equal to, sorry, f of x naught minus f of x2 is equal to a into x naught minus x2 all square plus b into x naught minus x2. And from this, f of x naught minus f of x2 is equal to minus a into, sorry, b into x naught minus x2 is equal to a into x naught minus x2 all square. And we change this into the terms of x1 and x naught and x1. So we get f of x naught minus f of x2 is equal, sorry, plus b into x naught plus x1 is equal to a into x naught plus x1 all square. And also from equation 7, we get f of x1 minus f of x2 is equal to a into x1 minus x2 all square plus b into x1 minus x2, and f of x1 minus f of x2 minus a into x1 minus x2 whole square is equal to b into x1 minus x2. And we change this into the terms of the slopes and also the x naught and x1. So we get minus delta 1 x1 minus a x1 square is equal to minus b x1, and also minus delta 1 minus a x1 is equal to, we cancel terms of x1, so we get minus b. Then to get b, delta b is equal to delta 1 plus a x1. This is a ninth equation. Then solving using equation 8, we have f of x naught minus f of x2 plus b into x naught plus x1 is equal to a into x naught plus x1 whole square, and f of x naught minus f of x2 is equal to a into x naught plus x1 whole square plus minus b into x naught plus x1. And we change this into the terms of x naught, x1 and also the slopes. So we get x naught delta naught plus x1 delta 1 equal to minus a into x naught plus x1 whole square minus b into x naught plus x1. Plus b into x naught plus x1. Then x naught delta naught plus x1 delta 1 is equal to minus a into x naught plus x1 whole square plus we use the we have the equation 9, so we can write the value of b here, delta 1 plus a x1 into x naught plus x1. And by expanding this and cancelling the terms, we get x naught delta naught is equal to minus a into x naught square minus a x naught x1 plus delta 1 x naught, and cancelling the terms of x naught, we get a into x naught plus x1 is equal to delta 1 minus delta naught. From this we get the value of a, that is a is equal to delta 1 minus delta naught by h naught plus x1 and b is equal to delta 1 plus a h1 and c is equal to f of x2. So we get the values of a, b and c. From this we can estimate the root. The root of the equation is the quadratic equation x is equal to the equation x is equal to minus b plus or minus root of b square minus 4ac by 2a, and from this we get the value as x3 minus x2. So because of the round of error, rather than using the conventional form, we use the alternative equation, that is x3 minus x2 is equal to minus 2c by b plus or minus root of b square minus 4ac, and from this we get the next value to be x3 is equal to x2 plus minus 2c by minus b plus or minus root of b square minus 4ac. So we get the root as x3, and we have here there is an error, relative error. The relative error is equal to epsilon is equal to x3 minus x2 by x3. So if the error is less than the tolerance, then we stop the iteration, then the roots must be x3. And if the error is greater than the tolerance, we get into the next iteration. For the next iteration, we modify the initial guess as x0 is equal to x1, x1 is equal to x2, and x2 is equal to x3, and we find the root and repeat this. The problem part will be explained by me.
So I think you got an idea about Muller's method. Now let's do an example. Please try to do. Okay. Consider the function f of x equal to x cube minus 5x plus 1 equal to 0. In Muller's method, we take three initial points. Take x naught. Yes. We are trying to we use three initial points to fit a parabola through them to find the quadratic formula to find the root. X naught equal to 0. Parabola. Yes. Initial condition. X naught equal to 0. X1 equal to 0.5 and x2 equal to 1. So firstly, we find the values of the function at these points. So f of 0 equal to 1, f of 1 equal to minus 1.375 and f2 equal to minus 3. Now we want to define h0, h1 and the slope. h0 equal to x1 minus x0, which is equal to 0.5 and h1 equal to x2 minus x1, which is equal to again 0.5. Now we define delta naught and delta 1. Delta naught equal to f of x1 minus f of x naught by x1 minus x naught, which is minus 1.375 minus 1 divided by 0.5, which is equal to minus 4.75. Similarly, delta 1 equal to minus 3 minus 1.375 divided by 0.5, which is equal to minus 3.25. Now we define A, B, and C quadratic polynomial, where A equal to delta 1 minus delta naught by h naught plus h1, which is equal to minus 3.25 minus 4.75 divided by 1, which is equal to 1.5. Also, B equal to delta 1 plus AH1, which is equal to minus 2.5. And C is equal to F of X2, which is equal to minus 3. Now to find the root, we have the equation x3 minus x2 equal to minus 2c by b plus or minus root of b square minus 4ac, which is equal to 6 pi minus 2.5 plus or minus 4.924. Here, doing this equation, we have two roots by doing the plus part and the minus part. But we take the root of which where what is the value, what is the sign of b to make the denominator to be large. So the root to be estimated to closest to the x2. So here the value of b is minus 2.5, which is a negative value. So we take the negative sign in the denominator. From here we get x3 equal to 0.1918. Now we get the root x3 as 0.1918. Now we calculate a relative error. The main benefit of Muller's method is we can calculate the error. The relative error epsilon equal to mod of x3 minus x2 by x3, which is equal to 0.1918 minus 1 divided by 0.1918, which is equal to 4.213. Here the relative error is very large. So we get into the next iteration. For the second iteration, we modify the initial approximation x0, x1, and x2 with the new x3, that is 0.1918. Now the new initial points are x0 equal to 0.5, x1 equal to 1.0, and x2 equal to 0.1918. We will do more iteration to reduce the error as much as possible. This is how the iteration goes. We stop the iteration when the relative error is less than the tolerance. Now we look into the Python code for this.
So let's go to the Python code for implementing Muller's method. We start by importing necessary libraries like NumPy for numeric calculation, about initialization. First, we define the three initial guesses, x0, x1, x2, 0, 0.5, and 1. And we also set a tolerance level of 1 into 10 raised to minus 6, which determines how close to the actual root we want beyond our solution. Then we define the function for which we want to find the root, which is x square minus 5x plus 1. And the lambda function allows us to calculate f of x for any x. Then we start the while loop. This loop keep iterating until we reach the tolerance level. Inside the while loop, we will calculate x1 minus x0 and x2 minus x1, which is the difference between the points, and we will assign it to x0 and x1. And after that, we will calculate the slopes between these points, which is assigned to delta 0 and delta 1. With these, we just take it manually. We have the function x square minus 5x plus 1 is called that.
Based on experiment minus factors plus one by equal. I think your point is equally one, it not equally zero. That this is not like in the parameter. X square minus 5 is plus 1. Then x equal to 0 is not like the parameter. Not the points. So these points are not like. I want to understand that the initial condition location stated where this is like the parameter. Now I want to know how you are saying that we are these are the points and they are like on the parameter.
We want to fit these points to parabola. If this not, we do again iterations for finding new roots.
And you're giving there will be not just like x not x1, x2, the x points. They can be any point. Parabola x-axis can be any point. But we are wrapping a function f at x equal to 0, what is f? Is 1. At x equal to 0.5, what is f? You have to calculate. At x equals to 1, what is f? You have to calculate. And since you are calculating f based on the parabolic equation, therefore they should lie in the parabola. Isn't it? So I confused you by saying that why you have taken x0, 0.5, 1. The rest is p to p, but finally the y point is decided by the parabolic equation. Therefore they will lie in the parabola.
Based on this, we will calculate the coefficients of the quadratic polynomial ABC, which passes through x0, x1, and x2. And after that, we will calculate the discriminant using the square root function. And it has two possible values, that is equal to b plus discriminant and b minus discriminant. And the if condition, will pick the largest of the two possible values. And then we calculate the next approximation x3, which is x2 plus h, which is minus 2 into c by the discriminant. And after that, we will check the relative error. And if the relative error is less than the tolerance level we set, we will take the x-ray as the next approximation. And if it's greater than, and if we have not reached the tolerance level, we will update the values x0, x1, x2, and the no values. We will update the x1, x1, x2 with the new values. And after that, we will plot this. We will plot this using the plot function. We will plot it using the lot. Blue line is for the function and the red dot is the X-scalar approximation. The red dot is for the approximation. Label it as using the legend function and using the show PLT dot show function to display the plot. So then take our
So, this is about an application of Muller's method in ECG. Here we import the libraries, NumPy, Matplotlib, SciPy, CMath, and we set a sampling frequency to 500 Hz, that is fs, and then we generate a synthetic ECG signal. ECG clean is equal to we generate a clean ECG signal. The signal is composed of two sinusoids. Then we generate a Gaussian noise with a mean of 0 and standard deviation of 0.5. By noise is equal to 0.5 into NP dot random. No, sir. I was yes, I was reading. No, sir. Now we plot the noisy ECG signal by using a PLT dot figure, PLT dot plot. We label the x-axis and y-axis. X-axis time and y-axis amplitude. Then we have to find the poles by using the Muller's method. The same code that Marin explained before. So we find the first pole and second pole using Muller's method. Then after getting the poles, we have to create the transfer function for filter. Then we filter the noisy ECG signal using the variable ECG underscore filter. Then we filters the noisy ECG signal, and then we plot the yes. So we import it from ECG underscore clean equal to yes. Does it remind of Fourier transform? It's a summation of two time series. So it must be a complicated signal. Can you show us the complicated signal? Only can you show us ECG without any noise? Can you show us only the ECG clean without any noise? Set noise should be zero. Set noise should be zero in your code and then project. Yeah, noise should be zero this time. Don't mess that up. Don't mess that up. Just below line, just below this noise equal to zero. Why this good guy is very unlucky and sad? What happened? Here,
Sir.
so you can see that this is a complicated looking signal, but again indirectly Fourier transform has played its role. Okay, we can see that they have just written this complicated signal as sum of two side functions, isn't it? So, and you can imagine like, it doesn't, it is not intuitive, right? If you just add two side function and just plot it, it will look something like this. Only people who have studied like Fourier transform and all can at least guess that yes, this guy is made up of sum of three sine term of cosine terms. But other than that, if you will show you to a layman, they will be confused. Reels and the shorts. Only reels and shorts. Nothing is in life.
So this is the noise ECG signal, and after filtering it, so this is the noisy ECG signal, and after filtering it, you will get image like this. This is the filtered ECG signal. Ten years. Guys.
And actually, you should talk about I was actually telling you about the low pass filter and high pass filter. And he actually showed me that. So, of course.
What happened?
So what is the first figure? What's the first figure? This is the noisy signal, is it? So this is the noisy ECG signal. Fine. What is pole 1 and pole 2?
The roots of
Roots of
the equation called non-linear.
why is it complex J? J is written, not J. Pole 1, this much J. X plus alpha. It's a complex number. Isn't it? So I'm not understanding why it is giving you complex number. What root are you finding? So the theme of this is continuing on our previous class. This is the Fourier transform of an origin signal. Okay. And what he is trying to do, we have to see like before and after filtering. Okay. Can you tell me what are pole 1 and 2? What are pole 1 and 2? What is pole 1 and 2? Right. What I see is most of the presentations. I see that you write the code and it is giving you the code and you are just presenting it. But at least try to understand what GPT is doing here, all the steps. Not able to understand like what is going on. What's the your chips? What is going on? This is what I meant.
The
If you make it, if you try to show it as a shiny code, then obviously why do you think that you want to do this all? So, and you know, it's different one of the what is 4 1 4 2? Why it is complex?
because
But I'm asking why the root was complex. What is so special in the function that the root is getting complex? What is the equation you are trying? Which is the root? These are the complex roots. By what are the equations? So it's wrongly suggested that this course try to don't know the try to write a code It's fine. Right, so it's not bad. But try to understand each line of the word, else something will happen. Okay, leave it.
Z square minus 1.6 Z plus 0.72. Question.
Okay. So it's a second order, the second degree, so you are getting two roots.
Yes.
And all the roots are complex, conjugate.
Yes.
Okay. Go to the figure. Yeah, this is the noisy ECG signal. Go down. Yeah, wait. Yes, so you can see the blue one is the noisy ECG signal, right? The blue one is the noisy ECG signal. Then the red one is the filtered ECG signal. How are you filtering it?
Using Moeller square.
You're filtering using Moeller
Now
square.
we find the എന്താണ് പറയുന്നത്?
So low pass means low. What do you mean by low pass filter? So suppose you have a signal. Suppose you have a signal, right? And you want only the highest part of the signal to get to. Sometimes you don't want low signals to get to. Okay? And so what you will do? You will allow the low higher signals, right? So if you allow the higher signal, that is known as a high pass. You are passing the high signals. That is known as high pass filter. Sometimes there will be small noisy terms. In your voice or in your video, there will be small noisy terms. You want to eliminate those terms. How will you do? You do a low pass. Okay, if you want those low signals to pass, then do a low pass. If you want to block those low signals, use high pass. Okay, then if you pass the high signals, block the low signals. Okay, like that Fourier transform is used to denoise the audio data, denoise the images also. That is one of the assignments for you, right? What is the assignment? Two assignments, right? One was audio, another was image.
No,
Audio. That's right.
No, myself Krishna. Good afternoon all, myself Krishna from DACS. We are group 8 and our topic is water distribution and network optimization. Our team members are Amrita, Anushka and Shweta. So first we will begin with the introduction. So water distribution is a very critical component of urban infrastructure, which ensures that the communities have reliable access to clean water. And at the same time, the water distribution system is facing a very vast number of challenges like efficient resource management, cost minimization, etc. And here comes the role of Simplex method. Simplex method is a very powerful mathematical optimization technique. It is often used to address these challenges faced by the optimization water design network. And we will look at a simple overview of what is Simplex method. So Simplex method is an algorithm for solving a linear programming problem and is particularly effective for maximizing or minimizing a function which is subject to a set of constraints. It was developed by George Dancing in 1940s and it iteratively moves towards the best solution by defined by a set of constraints. So in this presentation, we will be looking at the benefits of using Simplex method in optimization network, then how it can, then some real world applications of this. And we will look at a problem on the practical application and the Python implementation of the same. Next, we will look at the benefits of using Simplex method in water distribution. So the very first one is efficient resource management. So efficient resource management in water distribution is a very critical for ensuring that there is a reliable water supply for every area. So by adopting the efficient water resource system, management system or models, it will help in allocating a right amount of water to the areas which are in more need than the other, which will reduce the wastage of water. So the next benefit will be taken by Amrita.
Let's we look at the other benefits of Simplex method using water distribution and network optimization. The next one is cost saving. Cost saving is the most significant benefit. Simplex method has the most cost effective way to distribute water by minimizing transportation and pumping cost. In the case of water distribution cost, can include energy used to pump water, the labor of maintenance and infrastructure expense. The next one is scalability. The the scalability of these techniques allow for adjustment based on change in demand, supply, constraint or new infrastructure development without requiring significant change to the basic optimization model. Then we discuss about the real world application of Simplex method. The first one is urban water management. Urban water management include a network of reservoir, pumping station and pipelines that deliver water to various sectors. In situation where water scarcity is a major concern, such as dry cities or drought-prone areas, optimization can be critical for properly allocating limited water supplies. The Simplex method helps the determining the optimal flow through each part of the network to meet demands at various nodes, and water shortage are managed in controlled and fair manner. The second one is agriculture irrigation. In Simplex method, the Simplex method in agriculture irrigation help optimize water allocation, maximize crop yield, minimize cost, and ensure efficient water use. The third application is industrial water distribution. Many industrial depends on heavily on water for their production operation. Efficient water distribution can help enterprise reduce their manufacturing cost. Optimization ensure that water intensive process receive the appropriate amount while also recycle water where possible. This lead to cost saving on water supply and reduce waste water. Over to Anushka.
So, problem, a village has one reservoir and needs to supply water to two areas, that is area 1 and area 2. The goal is to meet the water demands of both areas while minimizing the cost of transportation. The cost to transport 1 unit of water from reservoir to each area is given as follows. So, the cost to area 1 is $2 per unit and cost to area 2 is $3 per unit. So we can write the optimal equation as Z equal to Z equal to 2x plus 1, 2x1 plus 3x2. And the reservoir can supply a maximum of 40 units of water. We can write that constraint as x1 plus x2 less than or equal to 40. Then area 1 needs 10 units of water. So that we can write as x1 greater than or equal to 10. And area 2 needs 2 units of water. X2 greater than or equal to 20. So the next step is to make the greater than or equal to inequality to less than or equal to. So for that, we convert this one to minus of x1 less than or equal to minus 10, and this minus x2 less than or equal to minus 20. Uh, to convert this inequality to equality constraints, we introduce slack variables. So for slack variables, for this equation 1, 2, and 3. And the equation 1 will become x1 plus x2 plus s1 equal to 40, and x1 minus. And the non-negativity will be x1 comma x2 greater than or equal to 0. So with this equations, we'll draw a table in initial simplex table. So here we'll write the corresponding coefficients of the previous equations. And Cj will be the corresponding coefficients of the main constraint, that is -2, -3, and 0. Pb will be coefficients of the basis, that is 0. And now we have to find the Zj. Zj is the sum of the products of Cb with the corresponding variables x1, x2, s1, s2, and s3. For x1, it will be 0, x2 also 0, s1 will be 0. Now we have to find Cj minus Zj, that is -2 minus 0, that is -2, and -3 minus 0 is -3, 0, 0, and 0. We'll take the most negative value from the Cj minus Zj. This is the entering variable, which is x2 for the next table. And from the RHS, we find the ratio by dividing RHS by x2, that is 40 by 1. So 40 by 1, that is 40. Minus 10 by 0 is 0, so we leave there. And minus 20 by -1 will be 20. So for taking the pivot variable, we take the intersection of this the entering variable and the smallest ratio, that will be -1. And the pivot variable should be converted to unit value for the next table. We should make this one as we should make -1 as 1, and the remaining values in the x2 should be 0 using row operation. We have to find the x1 and x2 values. No, using the simplex method.
That reminds me of I did slow.
Huh. So using row operation, multiplying with this R3, this S1, S3 column, sorry, row, into -1. So it will become 1. And the x2, this value will become 0 by adding R3. R3, the row third. So the corresponding S1 values will be changed. And the S3 will be replaced by X2. Since we have replaced S3 with X2, we don't have to look this column. So after the row operation, S1, 1, and RHS should be 20. final table will be looking like this. After the row operation, we have to make this table until this Cj minus Zj will become greater than or equal to 0. So after making this table, we'll get the x1 corresponding RHS as 10 and x2 as 20. So the main equation was Z is equal to 2x plus 3x2. To minimize this equation, we have found the x1 values and x2 value. So we'll equate this to this equation, that is Z is equal to 2 into 10 plus 20. That is 80. This is the minimum transportation cost for the this equation. Over to Sweta.
I'm going to talk about the Python implementation of the problem. First, we have to import the necessary libraries. NumPy and Matplotlib is used for plotting. Linear programming function is imported from the scipy.optimize module. This function is used to solve the linear programming problems, whether the goal is to minimize or maximize function. Here C represents the coefficients of the objective function, and A represents the coefficients of the inequality constraints. The list B holds the right-hand side of the inequality constraints. Then we have to specify bounds for each variable, where we give x1 equal to 0 to none, which means that x1 must be greater than or equal to 0. Then none indicates that no upper bound. Then we have to call the linear programming function. Where C is the coefficient of the objective function, A is the inequality constraint, and B is the right-hand side value, and B is the bounds. The method simplex is called. Scipy.
Yeah. Program.
It is used to solve the linear programming functions. It's an array of 500 equally spaced functions. So x1 equal to x2 capacity equal to 40 minus x1, which represents a function x1 plus x2 less than or equal to 40. And x2 area demand represents a function x2 greater than or equal to 20. And x1 area 2 demand represents a function x1 less than or equal to 10. Then we initialize the plot with an 8 into 8 inch figure. Then we plots the vertical and horizontal lines. Then fill between is used to shade the area. NP dot minimum function is used, which takes the minimum value for shading the constraints. We plot the optimal solution as a red dot. For that we use the function RO. Then we set the X and Y axis, limits, label, and title. So we displays a grid for better readability and shows the plot. Then we print the result. If the result is success, it prints the value of x1 and x2. Else it will show no optimal solution is found. Here 2f is used to round the decimal to 2 digits. It represents a function x2 less than or equal to 20. It is used to plot that constraint. That graph. To plot that function as a graph. In between, we'll shade that region. Shade that. Shade that region.
Then we got like X1 from other.
To shade that region. To shade the region x greater than or equal to 10.
I know the effort point is fine.
Then the shade item is- We are taking only X to 20 and X. Thank you also. Yeah. Very good. Thank you.
Good afternoon all. We are group 10. And I am myself, my name is Biju. Our team members are Rohit, Samuel, and Shinya. Our group presentation topic is recommendation system using SVD. So recommendation system is a system which is designed to suggest relevant items to users based on their preferences. They are using platforms like Netflix, Amazon, etc. They recommend content like movies, products, music based on the user's behavior. Recommendation systems drives user engagement by personalizing content. It enhances customer satisfaction and it is essential for filtering large amounts of data. There are mainly three types of recommendation systems. First one is content-based filtering. It recommends items similar to those the user has previously liked. And the second one is collaborative filtering. It finds similar users and recommends what those users like. The third one is hybrid systems. It combines both the content-based filtering and collaborative filtering for the better recommendations. Next is collaborative filtering breakdown. There are two types. First one is user-based collaborative filtering. It finds similar users. The second one is item-based collaborative filtering. It recommends similar items to the users. There is a limitation which struggles with new users or items. And I'll hand over to Sam.
So, all of you are familiar with what is SVDs, right? So SVD decomposes a matrix into three metrics. An upper triangular matrix U, a diagonal matrix sigma, and orthogonal matrix V transpose. So when we do recommendation systems, the upper triangular matrix will be a user feature matrix. The sigma will be a diagonal matrix of singular values, and V transpose is an item feature matrix. Uh, so uh, So when we use SVD for recommendation, it has an additional thing called latent factors. So what it does is it basically reduces the dimensions of the matrix, helps in decreasing the dimensions of the matrix, and helps in identifying hidden features which is not directly visible to the user. So applications of SVD and recommendations are start with the user item matrix, apply SVD to decompose matrix. It basically reduces the dimensionality by keeping only the top latent values. Reconstruct, and it can be used to reconstruct some metrics to predict missing ratings, and recommend items based on the predicted ratings. So the code. So this
Try to give it an example. So it's an interesting example. Can you explain the experiment?
So if we consider a matrix, if you consider a matrix, the rows will be mainly of users. So this would be user one, this would be user two, user three, and so on. And the columns, it would be of different movies. That is movie one. Can somebody say name a movie? Yeah. Any movie? So this would be Spider-Man 1. This would be Big Hero 6. So this could be any type of movie. And the ratings given by the user would be that. Babali, okay. So this could be any movie. And the corresponding ratings would be there. And yeah, Avesham and there goes this is Avesham. So and the ratings given by the user would be here. User one, the rating given by user one for manual boys would be there. User two, the ratings given by user two for manual boys would be there, and so on. So the aim is to recommend movies that are similar to Manual Boys. So if a user like Manual Boys, what other movies would he like? So we are basically recommending
Other movies, out of those four movies.
We are basically predicting what kind of movies the user would like according to the rating he has given for other movies.
Only four movies.
No,
Example.
no, there are. I think it would be better to show that.
Like I was, but I find the movies after a long day. From someone.
So we have a data set of movies, so it contains over millions of movies, now millions of ratings of different movies. I think, yeah. I think around 2,000 movies are there in the data set. So, so first is we are reading the data set using Pandas library. Then we are making a matrix of ratings because the initial data set contains so many advanced unwanted things. So we are basically cleaning the data for our use. Then we are normalizing the data, and then we are calculating the SPD using np.lionel.spd command. Yeah. Yeah. Then we have what is called a cosine similarity. So basically what it does is cosine has a range of -1 to 1.
Yeah.
So we take the cos product of two movies. So if the cosine value is -1, that means it is dissimilar. If it is 0, then it has no similarity. If it is 1, it is very much similar. So values near to 1 would be recommended to the users. Next is the recommendation of similar movies. Then this is a latent factors which will, as we increase this factor, the amount of recommendation quality would also increase. So it basically decides how much factor we want to extract from the limits. So that's it. Run the code as well. So
Those who are liking golden eye, they will also like the other ones.
other ones. We can also increase how many movies we want to recommend using the total.
Yeah, but then how can you establish a using that your other movies also they will like? Depends on the efficiency also, right? These are the movies suggested by for golden eye.
Yeah.
Okay, now you can change some quantity, change the movie to 20. So it became 20 movies. But then I am asking like whether if you get more movies than that, how much the similarity will change, like the satisfaction.
Basically, what it does is it creates an array on a descending order. So the values close to 1 will be on the top, and as we come down, it will decrease.
That means the similarity will decrease.
Similarity will decrease.
Golden eye.
Yeah. So a person liking golden eye would like Die Hard very much, but the probability of him liking rock is very less comparatively to that.
Yeah, this is a very, very nice example. I would say. I don't know if you've got it from somewhere or anything like that, but it's a very good classic example of SVD. I really like that we presented in that class. I cannot present it in that class, but I really like that example. Movie recommendations. And most importantly, they have shown SVD and also they use something like cosine similarity which I was examining master students who have gone to company and did their internship of 6 months and coming back. They were showing cosine similarities. But I'm happy that you with the first semester you explained your That's how it is.
And now the benefits of using SVD. One of the benefits is latent features. That is, we can predict the hidden patterns and hidden parts of the matrix or that review. And computational efficiency means reduce the size of the larger data which is to be processed, and the personalized recommendation provides accurate suggestions on based on the user interactions and user reviews. And there are some limitations for SVD, which is one of the limitations is cold start problem, which is the problem faced by the new users and new items. If some new users or new items enter to this, the review processing will be a bit difficult. And data sparsity, extreme sparsity of data set will may predict to a wrong prediction or something like that. Complexity requires computational resources, especially the large data sets. The real world use case of SVD is something like on Netflix, the movie recommendations just shown like in the Python code, and just similar to that on Amazon, they will recommend the products which is similar to the search history of that user or similar to the buying history of that user. And in Spotify, they suggest new songs which is similar they what they hear on the previous times, and like that on the e-commerce platforms using SVDs. And on concluding, SVD is a powerful tool for decomposing a matrix or factorization of a matrix, and it helps capture latent patterns in user preferences and offers accurate predictions. The future of recommendation system lies in combining various algorithms for more personalized experience. Thank you.
Presenting code or any matter. So one is internet resources. Only that way you present all the codes and that should be the what is that one slide equals to zero column number column? Yeah. Other than slides equals to column number column.
So that's the first J column.
But that is written on it. Yeah. Expect case follows from. No, I can go, that's it. That's no code. Go. So can you explain this line? Or you can just. Okay, data, API. Okay. Your title dot value is 0. Why value 0 is needed? Initial condition. No? Then if it is initially, then why are you printing it? Why are you printing it below that?
Getting the form of.
Yeah, but. But still you are accessing the initial value 0. So why are you printing it? It's just the initial, no? You have to run it for some more time, then you have to print. But why you printed only the initial, if it is the initial value? Why give you the minus?
To find which is not most not similar to that.
Why are you multiplying minus one?
Find the difference.
Depending on.
Most similar to that Miss movie which are like Golden Eye, which is
It is giving you minus one. That is bad. If it is minus one, then it will go down. Descending order means top, you don't want to come to the top. But if you do minus one, that accumulated is one and minus minus one. Even if it is having much similarity.
non G minus, and we can cancel the top which is not similar to the movies from the top.
Was any other group where? No, right? Done. Every group is done, no? There's no one, right?